So good evening, everyone. We will be waiting for 5 more minutes for everybody else to join. We'll start at 6:05. Hello, can everyone hear me? Can you please confirm? Hello, Ashwin, can you hear me? Can you?
Hello,
Okay, okay.
I can
Can
hear.
okay. Thank you. So we'll start in just 5 minutes. We will wait for some more time for people to join.
Yes, sir.
Okay. You can screen my screen also, right?
Screen is visible.
Visible, right?
Yes,
Okay.
I am unmuting because if it is not unmute by everyone, then there will be a disturbance in lecture. So if everyone is mute, then one person is talking, then everybody can listen. So I am
Yes.
unmute.
Yes. So we'll wait 2 more minutes and we will then start. So then let us start. If people wants to join, they will join afterwards. So good evening, everyone. So my name is Mr. Bharat. So I am a doctoral student at Chemical Engineering Department of IIT Kanpur, and I am also the PMRFTA for this course, for this NPTEL course of Thermodynamics of Fluid Phase Equilibria, taught by Professor J.N.K. Singh at the Department of Chemical Engineering at Kanpur. So today we will start. So I hope you have gone through the week 0 and week 1 assignment and all the lectures as well. And at the end, I will ask. So first, I will take some sample problems, and at the end, I will ask if you have any questions or doubt, and then we can discuss them at length. So the first, so we are going to discuss the week 1 questions, sample problems. So the first question which we are going to discuss is, which among the following is an intensive property? So we have 4 options present here, and out of these 4 options, one option is the correct option. So it's a single MCQ type of question in which only one question, one option is correct. So the first question is, which amongst the following is not, remember, it's not an intensive property. That means we do not want a property, we want a property which is not an intensive. So first, let us understand what is an intensive property. So when we say property, there are 2 types of properties. So one is the intensive property and the other is the extensive property. So intensive properties are basically the properties, thermodynamic properties, which depend on mass. Those are the extensive properties, and the properties which do not depend on mass are called as intensive properties, right? So here what we are asked is not an intensive property. That means we want an extensive property, right? So this is a tricky question in which instead of asking straight away which of the following is an extensive property, the question is a twisted one in which the examiner asking not an intensive property. So that means we need an extensive property. So does anybody of you want to guess what would be the answer? So Narsimha, are you there? Would you like to answer?
Hello.
Okay, Ashwin.
Uh, Intensive is independent.
Yes,
Okay.
intensive is independent, right?
So mass is independent. Okay.
Yes,
This density is also independent,
yes,
and pressure is also independent.
yes.
Specific is divided by quantity. So specific will also not be dependent. So all are independent. So
So you think none of the option is correct, right?
all four are all four are not dependent on this one uh, mass. All
Okay,
four all four are independent of mass.
yes. So okay. So Narsimha, would you like to answer? Okay. So Ashwin, so remember, it is not an intensive property. That means we want an extensive property, right? That means the property which depends on mass. So specific heat capacity, it doesn't matter. Let's say, for example, we have either 1 kg of water or half kg of water. The specific heat capacity, that means, wait. So that means the CP of water is going to be 4.18 kilojoule per kg, right? At some temperature, at room temperature, right? So this doesn't depend whether it's 1 kg of water or half kg of water or whatever kg of water, right? So this does not depend on mass, right? Similarly, density of water, whether it's 1 kg or half kg, it does not depend on mass. That means, okay, so we want an extensive property, that means which depends on mass, right? So this does not depend on mass, this also does not depend on mass. Similar is the case with pressure. So we have, let's say we have a container. In this, let's say we have some half kg of air or 1 kg of air. It doesn't matter what is the amount, it is the pressure is always going to be whatever the value. So this is also not an this also doesn't depend on mass, but mass depends on itself, right? That is why the answer is, this is an intensive property, this is an intensive property, this is an intensive property, but this is an extensive property, right? Because it is, mass is dependent on mass itself.
Yes,
Right? So that is why the, you can see the, this is a tricky question that in which the examiner has given first answer only correct. So you think that all of them are wrong. So it's a tricky question. Okay. So anybody has any doubt? So the answer is A. We have our answer. The answer is A. This is an extensive property, right? So then now we'll move. If anybody has any doubts, they can ask. Otherwise, I'll wait for 1 minute if anybody has any questions. Otherwise, we'll go. Right. So answer is mass, right? Why? All properties which depend on no mass are called as extensive properties, and the properties which are independent of mass are called as intensive properties. So we want an extensive property. So let us now move on to the next question, right? So the next question is, a system that does not permit transfer of matter but permits transfer of energy between system and surrounding is known as, option A is isolated system, option B is closed system, option C is open system, and option D is none of the above. So if anybody wants to answer it, anybody wants to try? So let us understand the question, right? A system that does not permit matter. So first of all, let us understand what is a system. So in thermodynamics, we have two things, right? A system, let's say a system, this is a system, and this is the surrounding. The highlighted part is surrounding, right? So system plus surrounding equal to universe. So if you have a glass of water, let's say a container filled of water, so you draw a boundary around it, and so this is our system. So system is what we study, and if you leave whatever comes out of this boundary is called as surrounding. Okay, so this is what the examiner wants to ask us, that this is the system, and then we draw a boundary, and this is surrounding. Now what he is saying is, it permits transfer of matter. That means, let's say there is water, so this water can go from system to surrounding, right? But energy it cannot permit. That means this is an insulated system. That means here heat or work cannot cross the boundary, right? And then what he's asking is isolated system. So let us first understand then what is an isolated. So as the name, from the name you can say it is an isolated. That means this is system, we consider this is system and this is surrounding. So this, there is no interaction between system and surrounding. Neither the mass passes from system to surrounding, nor the vice versa, nor is the energy is getting transmitted in the form of heat or anything. So isolated system will be a system in which neither the in which delta M equal to 0 and delta E. So here E stands for energy. Delta E is equal to 0. So this is isolated system. A closed system, or let us go from here to here. So what is an open system? So open system is system, and then here we have surrounding. So it allows both transfer of mass. Delta M is non-zero, and delta E is non-zero. So that is open system. Okay, and closed system, it allows delta M is equal to 0 for closed system, but delta E is non-zero, right? That means, in short, what we can say is, if we have a open system, so this is open. So for open system, it can exchange, system and surrounding can exchange mass as well as energy. So both of them non-zero, right? This is open. If in open system, you make an arrangement where energy transfer cannot occur, so that is called as a closed system. Okay, so closed system, delta M equal to 0, but energy not equal to 0, right? It can exchange energy. And isolated will be closed system, you put interact heat transfer heat transfer equal to 0, it does not exchange. So then it will be isolated, so in which delta M is also 0 and delta E is also 0, right? So with this, let us check what it has. Does not permit transfer of matter. That means delta M is 0, but permits transfer of energy. That means delta E not equal to 0. So which one is it? It is this one, which is a closed system, right? So anybody has any question? Okay. So when the system does not allow mass energy to exchange, so the boundary surrounding the system is called as a dithermal bond, right? Dithermal boundary. So that will come afterwards. So it's an additional information. So our answer is closed system, right? So anybody has any questions? I will wait for 1 minute. Then if nobody has, we'll go for the next question. Okay. So answer is closed system. A closed system permits transfer of matter. So matter here means mass between system and surrounding, but flow of heat is not allowed. Okay. So next question which we have, a system that permits transfer of both matter as well as energy between system and surrounding is known as. So anybody would like to try? Just now I told. So Ashwin, you would like to try? Okay. So what we have is that permits both the transfer of matter. That means delta M not equal to 0, delta E not equal to 0, right? So which system will it be? Will it be an isolated system? Will it be a closed system, or will it be open system. It will be a open system, right? Let me repeat again. I will again tell. So when delta M not equal to 0, delta E not equal to 0, we have open system. Okay. When delta M equal to 0, delta E not equal to 0, we have a, sorry, delta M not equal to 0, E is equal to 0, we have a closed system. And when delta M not equal to 0, E not equal to 0, then we have a isolated system, right? So by this definition, we have open system, right? So the answer is open system. Okay. Does anybody have any doubt? So I'll wait for 1 minute and then we can go to the next question. So let us go to the next question, right? So which we have, which among the following when in operation is an example of an isolated system, right? Isolated means delta M equal to 0. There is delta M equal to 0 and delta E is also equal to 0, right? So kettle boiler. So in kettle boiler, what we have? We input the heat into it, right? We have a kettle in which we have water. So we heat it, right? So that means delta E is not equal to 0. That means this is not an isolated system. Thermoplast. So what we have thermoplast is like this, and we put water and it is closed. So it, for this, delta M is equal to 0 as well as delta E is equal to 0. So this can be a isolated system. But let us not stop here. Let us go. So kettle will be delta M equal to 0, delta E not equal to 0. That means kettle will be a closed system. This is the isolated system. Frying pan. So in frying pan, what we have is both delta M not equal to 0, delta E not equal to 0. So this is an example of an open system. Air condition. So air condition is also not an isolated system. That means only the correct option is option B, which is thermoplast, which can also be obvious because we use thermoplast to, let's say, keep our hot water. Thermoplast is there, we put in hot water and it stays hot for a large amount of time, right? That means energy transfer is 0. So that is basically, even if you don't have the concept, you don't know the concept, you should be able to answer it, right? Energy loss is 0. So is the mass loss. So correct answer is thermoplast, right? Thermoplast. So anybody has any question? So I will wait for 1 minute. And if anybody has any question, they can ask. Otherwise, we'll go to the next question. Okay. So no questions. So I assume everything is clear. And then we go to next question. So what is the next question? If the direction of a process can be reversed at any point by an infinitesimal change in external condition, then the process is known as, the option is reversible, irreversible, partially reversible, and none of the above. So would anybody of you would like to try? Right. So first let us understand what is a process. So let us consider that this is a thermodynamic diagram in which y-axis represents pressure and x-axis represents volume. So let us assume that this is the point 1. So when you go, so this is the initial state of the system. So when you go from 1 to 2, so this is initial, this is final position, right? And the direction of the process is like this. So when system goes from certain setup, so here pressure will be P1, volume is V1, so here it will be P2, V2, right? So when system changes its position from an initial state, so when a system changes its position from an initial state to final state, so this phenomenon is called as a process, right? Thermodynamic process. Okay, and then comes types of the process, right? So process can be divided into two types. So one is reversible, another is irreversible. So what is a reversible process? So reversible process is a process. The reversible process is a process in which when system goes from point 1 in its initial state to final state, each and every step, each and every the path which it follows, it's we can break it up into very infinitely very slow process. So that would be a reversible process. So each and every step of the reversible process is quasi state equilibrium. That means if we go from here to here, we are able to go from backwards also. At any step, the process can be reversed, right? So what it is saying is, so this is a reversible process. An irreversible process would be a process which happens very fast. So like for example, you have a hot water. Let's say you have a hot water. Let's say at temperature equal to 90 degree, 90 degree centigrade. So you put this water into a surrounding or in the ambient temperature in which T ambient is 10 degree centigrade. So spontaneously it will transfer from hot body to cold body. That means it's an irreversible. It will be an irreversible process because it is happening spontaneously. So all spontaneous processes are irreversible, whereas very slow processes are all the spontaneous processes are irreversible, whereas slow processes are reversible, right? So here what the examiner asking us is if the direction of the process can be reversed, right? At any point by an infinitesimal change in an external condition, then the process is, like I said, reversible processes, we can change the direction. So as it is an infinitely small process, infinitely slow process and can be reversed, so the answer will be, you guessed it right, reversible process, right? So very slow processes, infinitesimal slow process are called as reversible, whereas spontaneous processes are called as irreversible, right? So anybody has any question? So I'll wait for one more minute and then we can go. So this is the answer. If a direction of a process can be reversed, we have a reversible process, right? Reversible. The explanation is process which can be reversed at any moment and can bring both system. So here this word has to be highlighted, right? Which is both, right? Both system and surrounding. So there can be a process in which only system can come back. Like for example, we can have a glass of water at 90 degrees centigrade. We put it in environment at T, let's say 20 degrees centigrade. So it will lose heat and eventually the temperature will become 20 degrees centigrade, right? But then we can again heat this to again bring its temperature to 90 degrees centigrade. So we can have a process in which system again comes to its initial position, but the surrounding would have changed. So here the temperature, let's say, becomes 20.001. So that is why this both is very important. This is a process which brings both system and surrounding to its initial position. Then and then only we call that process as a reversible process. Okay. So anybody has any question? Otherwise, there can be a process in which only system can come back to initial position, and then in that case we will not call it as a reversible. We'll call it as a irreversible. Right? Anybody has any question? So then we'll start with the next question. So what is the question? So the property whose value in a prescribed state is independent of previous history of the system, right, is known as which? Okay, so first let us understand what is a thermodynamic property, right? Property independent of the history. So let's say you have a container which has air in it, right? And we say it is a temperature, let's say 20 degrees centigrade, pressure equal to 1 atmosphere, and volume, let's say, is 1 meter cube. So as soon as we say that these three properties are fixed, we define the state of the system. Now we do not care what was the state of the system before this, right? That means this completely described our system. This set of properties completely describe our system. So such quantities is called as a property, right? So another mm, what I can say, another characteristics of properties, we can write a complete differential of a property. So let's say M is a thermodynamic property, which is a function of x and y, right? So we can say this is equals to del m by del x. So these are partial derivatives at constant y, dx plus del m by del y at constant x dy. Okay, so this is another characteristics of property, and property is a continuous function. That means its that means the double derivative remains the same. That means del 2m by del x del y should be equal to del 2m by del y del x. So it does not matter how we take. So this is basically a definition of property. Okay, so now what let us go back to the question again. Let me first remove this. Okay, so we have a property whose values in precursor is independent of the history. See, independent. So it's a state function. Like for example, temperature, it's a, so all the properties are always state functions, right? That is one of the characteristics, that is one of the requirements for a particular thing to be called as a property. So temperature is a state property. It doesn't depend on the previous state, right? We do not care how the system arrived at that particular temperature. We just care what is the temperature. Similar is the case with pressure. We do not care how this pressure was being established. We just care what is the pressure. Same goes with the volume. But there are other quantities which are path function. That means which depend on how we reach, which is called as so for some example would be the heat. So this will see next week. So heat is a path function, right? For example, we have system here, system here. So we go from here to here. there are many ways of going. Like this we can go, like this we can go, like this we can go. So the heat, the path functions will depend on the path. So if we follow this path, the path function, let's say heat Q will be some Q1. If we follow this path, it will be Q2. If we follow this path, it will be Q3. And it's possible that Q1 not equal to Q2 not equal to Q3, right? But so such quantities are called as a path function. But a state function, like for temperature, so irrespective whether we follow this path or this path or this path or this path, so that state function will have the same value here. Here it will be T2, let's say T1. So property whose value is in prescribed state is independent. So this word is very important. Independent of previous history of the system. These are state functions. So the correct answer would be B, state function, right? So anybody has any questions? I will wait for 1 minute if anybody has any questions. If nobody answers, ask, then we will go to the next question. Okay. So what is the answer? B, state function. The state functions are the thermodynamic properties which depend only on initial and final. So this is very important, initial and final state of the system, and are independent of the part taken to go from initial state to final state, right? So now I'll wait for 10 seconds. If anybody has any questions, they can ask. So we'll go to the next question. So what is the next question? Thermodynamic equilibrium implies what? Thermal equilibrium, mechanical equilibrium, or chemical equilibrium, or all of the above. So we know that thermodynamic equilibrium means change in pressure or change in temperature has to be zero, change in pressure has to be zero, and change in chemical potential has to be zero. So chemical potential is what we will be talking very in detail in the subsequent lecture, right? So thermodynamic equilibrium implies delta T is equal to 0, delta P is equal to 0, and delta mu is equal to 0, right? So delta T equal to 0 means what? Thermal equilibrium. Delta P is equal to 0 means mechanical equilibrium. And delta mu equal to 0 means chemical equilibrium. So thermodynamic equilibrium means thermal equilibrium plus mechanical equilibrium plus chemical equilibrium. Right? That means it is A plus B plus C. That means the answer will be option D, all of the above. Right? So the answer would be all of the above. Right? All of the above. Thermodynamic equilibrium plus thermal equilibrium plus mechanical equilibrium plus chemical equilibrium, that means all of the above, right? A system is said to be in thermodynamic equilibrium only and only when it has achieved thermal, mechanical, and chemical equilibrium, right? Anybody has any questions? So here I will ask a homework question, which I hope you can try to find, and then if you are able to answer it, we can discuss it in the next class. So the question is, what is the difference between steady state and equilibrium? right? Equilibrium. So this is a question, homework question. Does the steady state imply equilibrium, or and equilibrium implies steady state, or what is the relation between them and what is the difference between them? Steady state. So if you have taken an undergraduate course on heat transfer and mass transfer, so there we say steady state. And in thermodynamics, we always deal with equilibrium. Very rarely do we deal with steady state. So this is the takeaway question. What is the difference between steady state and equilibrium? Right? Similarity and difference. Right? So then we'll go to the next question, and this question we'll discuss it next class. Okay. So the question 8 is, which of the following is not a characteristics of reversible process? Right? So remember, when we say reversible process, so reversible process is an infinitely slow process. Okay. So that means the driving force and opposing forces are in exact balance, right? And as it is a very slow, this condition is correct, right? Which of the following is not? That means this is a characteristics of steady reversible process, because only when the difference in the, let's say this is the block and we are trying to displace it using this force F, and there is no opposing force, and this mass is m, so it will move very fast with an acceleration F a is equal to F by m. But when there is an F, so here F plus df, and here F is the opposing force, so then the acceleration will be df by m. So that means if there is only slight pressure, slight change in the force, then we can say it's a reversible process. So this is a characteristics of reversible process. Friction, turbulence, and other dissipating effects are absent. So this is also characteristics of reversible process. Takes an infinite amount of time for its completion. As it's a very slow process, reversible process, it will take infinite amount of time. That means all A, B, C are the characteristics of reversible process. And we are asked, remember, we are asked not. So this is again a tricky question. So which of the following is not a characteristic? But we say A, B, C, all are characteristics. That means answer is none of the above. All the options A, B, C are the characteristics of reversible process. Okay. Anybody has any question? We'll wait for 1 minute. See, none of the above. So correct answer is none of the above. All A, B, C are describes the properties of reversible process. Okay. So this is a now next question is quite an interesting one. Internal energy change. Okay. So what is internal energy? We usually in the textbook, people usually use E, delta E, or delta U as a representation for internal energy, right? So we are talking about this. Both of the nomenclatures are fine. So internal energy change of a system over one complete cyclic process. Okay. So what is a cyclic process? Let us first discuss that. So let's say we have a P and V, and this is the initial point. So cyclic, we know from the word cycle. Cycle means we start from one point, we do something, and then we again end up at the initial point. This is essentially the requirement for a process to be called a cyclic process. We start at some point and then we end up. So this is a cyclic process. Let's say this is the starting point. So this is also a cyclic process because we are coming. Okay. Then this is also a cyclic process, right? Because we are coming. However, this is not a cyclic process because this is the starting point, this is the end point. So system does not come to its initial position. This is not a cyclic process. This is 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 a cyclic. Okay. And when all the steps, so additional information which I am giving is, so a cyclic process can be of two types. It's a reversible cycle or it could be irreversible cycle. So like for example, if we take this way, it's a cyclic process because system is coming back to initial position and we can break down this process into 3 steps. So this is, let's say, 1, 2, 3, 1. So 1 to 2, this is a one process. So cyclic process. So this is one process. 2 to 3, it's another process, and 3 to 1, again another process. So if all the processes in a cyclic process are reversible, then we say it's a reversible cycle. So this is what will come in. We will see later that Carnot heat engine, right? So that we will see in subsequent lectures. That cyclic process, when all the processes inside it are cyclic, are reversible, we call it a reversible cyclic process. And if at least any one, let's say for example 1 to 2 is irreversible, whereas 2, 3 and 3, 1 are reversible. This is irreversible, this is reversible, this is reversible. So then the whole cycle becomes irreversible. But if all are reversible, the whole cycle becomes reversible. Okay. So now let us go back to the question. So the question is internal energy change of a cycle over one complete cyclic process. So as we know that internal energy, so here comes the first law, that internal energy is equal to delta E is equal to delta Q plus minus delta W, depends on what convention you are using. So as system is coming back to its initial position, the delta E, which is a state function, right? So state function depends only on initial and only on the current state. So as, let's say for example, when it is starting, its internal energy is E1, and when it comes back to its initial position, again its energy is E1. So change will be 0, right? So internal energy change of a system over one complete cyclic process. The cyclic process is very important. So the correct answer is 0, because internal energy is a state function, which depends state function, which depends only on initial and final state. Okay. So anybody has any question? So let us first remove. Okay. So internal energy is a state function, right? And state functions are the functions, thermodynamic function, whose value depend only on current state of the system, and state function depend on initial and final position. As in complete cycle, the system comes back to its initial state. The change in internal energy is same. That means here it should be 0, right? And state function do not depend on path, right? So this is wrong. This is also wrong. This is also wrong. The correct is 0. So anybody has any question? I'll wait for 30 seconds and then we can go to the next question, right? So we'll go to the next question. So the first law of thermodynamics is nothing but law of conservation of what? Momentum? No. Mass? No. Energy? Yes. Okay. So first law of thermodynamics is energy. So let us understand. I will discuss all the laws of thermodynamics. So how many laws of thermodynamics are there? There are 4 laws of thermodynamics. Zeroth law, first law, second law, and third law. So zeroth law, what does it say? That if system A is in equilibrium with system B and system B is in equilibrium with system C, so that means A and C are in equilibrium. Okay, what is first law? So what is this? So this essentially tells us that if A and B are in equilibrium and B and C are equilibrium, that means there has to be a property which we now know as a temperature, which is Ta equal to Tb is equal to Tc. Okay, so basically, the 0th law of thermodynamics tells us that there is property. Basically, it gives us the definition of temperature. That means when A and B are in equilibrium, B and C are in equilibrium, there has to be something which is common in between all of these three things. Eventually we found out that that something which is common is called as a temperature, and then we can say that temperature of A equal to temperature of B equal to temperature of C. Okay, what does first law of thermodynamics say? So the expression is delta E is equal to delta Q plus minus delta W. So first law of thermodynamics basically tells us that energy, heat transfer and work done, both are form of energy only. Okay, but it does not tell us that how much amount of work can be converted. So basically it tells us that work and heat are interconvertible, such that delta E remains the same. Okay, however, it does not tell us that how much amount of heat can be converted into work and how much amount of work can be converted into heat. Okay, so it tells us that heat and work are interconvertible and both are form of energy only, but the amount can we convert to full amount of heat into work or full amount of work into heat. It does not tell us that. First law does not tell us that. That is where second law will come. So second law basically defines a state function called as entropy, which is denoted as S. So basically what entropy tells us that heat is a lower grade of energy. Okay, heat is a delta E is equal to delta Q plus minus delta W. So heat is a lower form of energy, lower grade of energy. That means entire amount of work can be converted into heat. Conversion of work to heat is 100% thermodynamically possible, whereas conversion of entire amount of heat into work is thermodynamically not possible. That is why we can say that the solar cells which are present in which the sun is exerting energy in the form of heat, right? So 100, let's say the energy which is given out by sun is E. Okay, so the total entire amount of energy radiated by sun in the form of heat, which is Q. Solar cell cannot convert 100%. We cannot have a solar cell with a 100% efficiency. Some amount of, because thermodynamic limitation is there in which it says entire amount of heat cannot be converted into work. However, work can be 100% converted into heat. So that is the second law of energy, second law of thermodynamics. And third law, what is third law? Third law tells us, basically gives us that entropy at of any substance at absolute temperature, that means 0 Kelvin or minus 273.15 Kelvin is 0. Okay, so those are the 4 laws of thermodynamics. Okay, so let us come back to the question. Okay, so let me first erase this. Okay, so what is the question? The question is, the first law of thermodynamics is nothing but the laws of conservation of energy. So the correct answer would be energy. Okay, it is not momentum, it is not mass, it is not none of the above, it is energy. So anybody has any question? I'll wait for a minute. Nobody asks, then we'll go further. Okay, so correct answer is C, energy, right? Anybody has any questions? Okay, so let us go to the next question, which is, which of the following statement is correct? So all reversible processes are quasi-static process, all irreversible processes are quasi-static processes, all quasi-static processes are reversible, and none of the above, right? So which is the correct answer? So let us first understand what is a reversible process and what is a quasi-static process. So reversible processes are infinitely slow processes, right? In which both system, both, this is very important, both system and surrounding comes back to initial position, right? Position. That means if we were to draw it on a thermodynamic diagram, let's say P and V, this is the initial position, this is the final position, and if we go from here to here like this, then a reversible process would be able to retrace this path. Again, thermodynamically, we in a reversible process, if this is the initial path, we can trace back the exact same path. So such processes are called as reversible processes. Okay, and quasi-static. What are quasi-static processes? So quasi-static processes are infinitesimally small processes, right? That means this is a state of quasi-static process and reversible process, right? That means let me remove it first. So okay, so this is the correct answer, right? All reversible processes are quasi-static process. That means the main criteria of a reversible process is that it should be the infinitesimally small process, and quasi-static processes are the infinitesimally small process, right? That means hence we can say all reversible processes are quasi-static process. However, all quasi-static processes are not reversible. That means are not reversible. That means we can have a quasi-static process that is a extremely slow process, but it can be a irreversible as well. Okay, so all reversible processes are quasi-static process. However, the reverse, the converse is not. Okay. Okay. Quasi-static processes involve entropy generation, which are irreversible. Hence, all quasi-static processes are not reversible. However, reversible processes are quasi-static processes. Hence, option A is correct. So, if anybody has any question, they can ask. Else, we'll go forward. Okay. So this is a very good question, which summarizes all the concepts about the laws of thermodynamics, which we have studied till now. Okay. So let us start. So what is the question? So match list 1 with list 2 and select the correct answer using the code below. Okay. So we have to find, basically it's a match the pair sort of a thing. Okay. So what is the first law of thermodynamics? Entropy of pure crystalline substance is zero? No. We know that this is a third law. Okay. Like I said, entropy at absolute zero, which is absolute 0 Kelvin, is equal to 0. So pure crystalline substances, that means substances at absolute 0 temperature. So this is third law. Okay. Spontaneous processes occur in a certain direction. Okay. That means it's an spontaneous means irreversible, right? Then so this is like only one of them is correct, right? So we have many options here and only 4 options here. If two bodies are in thermal equilibrium, that means we have A equal to 3. A equal to 3, right? Then we have, if two bodies are in thermal equilibrium with a third body, then they are also in thermal equilibrium with each other. Obviously, this is 0th law, right? That means C is equal to 4, right? Then spontaneous processes. So we'll go to D, the law of conservation of energy. We know this is first law, right? So this is first. So B, let's say we don't know. Then we go to D. So what is D? Law of conservation of energy, it's a first, right? So D is 1. So here what we have is perpetual motion of its first can boil it. So this is which? This is which one? This will be the first law, right? Because first law what we have, delta E delta Q plus minus delta W, right? So let me first erase this. Okay. Okay. So what is E? E is also 1, right? So I will write here E is equal to 1 first law, right? Then like I said, complete conversion of heat to work is not possible, as this violates the second law, right? Because what the second law tells, first law tells us that delta E is equal to delta Q plus minus delta W, which first law basically tells us that heat and work both are forms of energy, and we can convert heat into work and work into heat. Both are interconvertible. However, first law does not tell us how much amount of heat can be converted into work and how much amount of work can be converted into. That is the second law, which tells us that heat is a lower grade of energy, whereas work is a higher grade of energy. We cannot convert all the heat into work, but all the work can be converted into heat. Right? So this is second law. That means F is 2. Right? And this is the correct answer, right? Okay. Does anybody have any questions? I will erase it. So the correct answer is option C, right? What we have is option C. What is the explanation? The entries of list 1 are definitions of entries of list. So this is basically, these are, so there are many definitions of each law of thermodynamics. Okay. So we have option C. Okay. Option C is the correct answer. Okay. So now we go to the calculation part question, calculative question. Okay. What is the question? A system while undergoing a cycle. Okay. Cycle, that means it should come back to its initial position. So here you see A, B, C, D back to A. So this is indeed a cyclic process, and it has the values of heat and work transfers as given in the table. What we need to do is find the power developed. Okay. So to understand, so we have this. Let's say this is some P, this is some V. This is the starting point A. So let's say it is going from A to B this way, B to C like this. This is point C. This is, let's say, point D, and it is coming back to its initial process, right? And so here, like I said, Q and W both are part dependent. So here Q is positive, W is positive. Okay. Here B to C, Q is negative, W is positive. Then C to D, it's negative, negative, and D to A is 75 and 0. Okay. And we are asked the power, right? We are asked what is power. So power will be what? Change in work, right? Which will be 474 plus 474 plus 0 of, so delta W will be what? So let me first erase it. So power is equal to delta W, and delta W will be what? WAB delta plus delta WBC plus delta W C to D plus delta W D2A. So which is plus 474 plus 0 plus minus 180, okay, plus 0, okay, which is how much? Which is equal to, I am writing here 474 minus 180. So remember the unit. The unit is kilojoule per minute. Okay. So let me remove this. Okay. Okay. So this will be what? 492. Right. This will be kilojoule per minute, and we have option in, we are asked in kilowatt, right? Kilowatt. What is kilowatt? Kilowatt is nothing but kilojoule per second, right? So we need to convert this minute to second. So how do we do it? We just divide it by 60. This will be kilojoule per second, okay, which corresponds to this value, right? Okay, 4.9 kilowatt. Okay. So here you can see, let me first remove this. Okay, so what we have is 4.9. So what is the network? This is nothing but power, which is 470 plus 0 plus of minus 180. So here plus indicates work is taken out of the system, and minus indicates work done by the system, right? So this is okay. So minus 180, which is 294 kilojoule per minute. But as we are asked in kilowatt, we divided by 60 and we get kilojoule per second, which is nothing but kilowatt. So W is missing here. It should be kilowatt. Okay, 4.9. Okay. Does anybody has any question? So we'll wait for 1 minute. And if anybody has any questions, they can ask. Okay. So this is a very good question. Okay, so we'll go to the next question. So here what we have is TV diagram for the heating process of water. Okay, so it's a pure component water. Okay, and it's a TV process. Okay, TV diagram. So here we have temperature in degree Celsius and volume, some unit. Okay, meter cube, let's say. And initially it's at this point, then it goes to 0.2, it's 0.3. So here P equal to 1 means throughout this process, the pressure remains same. And what are we asked? Let me remove it. So we are asked match the following. Okay. Let us put like this. Okay. So what is the 1 to 2 path? What is this part where whether it's a saturated vapor or vapor liquid mixture or compressed liquid? 2 to 3 and 3 to 4. So here let us consider there are two ways of solving it. One is that you know the PV curve of a pure substance, right? As this is a pure water, so one would be that you know that it's a pure water and you know the TV diagram, okay, like this, and then you can clearly say what this is. The other way is, which is a more logical way, which I am going to tell. Okay. So here, let us consider this is some, we don't know what it is. Yeah, it's either liquid water or vapor water, we don't. But what is happening here is you are increasing the temperature. Okay. So as you are increasing the temperature, the volume is increasing, right? That means, let's say, for example, you have water at T is equal to 20 degrees centigrade, right? So you heat it to 30 degrees centigrade. Okay. So what is going to happen? Let's say if it's with the pressure constant, right? Because it's a isobar. Okay. So pressure is going to remain constant. So with constant pressure, you heat water. So what is going to, let's say this is V1, this is V2. Obviously, V2 will be greater than V1, right? Basically, volume, as you are increasing the temperature, the volume is also increasing linearly. Okay. So then you heat it 30 degree, 40 degree, 50 degree, let's say 90 degree, and then you reach 99 degree, and then you reach 100 degree. So this is the point of 100 degrees, right? And this is, let's say, 20 degrees. So this is okay. So then after you heat, the temperature remains constant, the volume, okay, the temperature remains constant when volume is increasing. So this represents the phase transition. That means all the amounts. So this is a coexistence curve in which there is a liquid also and vapor also. What is happening when we go from here to here is the amount of liquid is decreasing and amount of vapor is increasing. So it's a two phase system. And then at point 3, so let's say, for example, here 90% is liquid, 10% is vapor. Here 50% is liquid, 50% is vapor. Here 60% is vapor, 40% is liquid. Here 90% is vapor and 10% is liquid. And here at point 3, all the liquid has been converted into vapor. Okay. So this is a phase transition. So this is L plus V. And afterwards, only slight increase in temperature, volume increases. That means this is a vapor. Okay. So this is pure liquid. This is liquid plus vapor. And this is pure vapor. Okay. So 1 to 2, liquid only. 2 to 3, liquid plus vapor. And 3 to 4, only vapor. Okay. So let us check the options now, whether we have it. So let me first erase it. Okay. So actually this is there is a correction in the question. This should not be water, because for water the temperature will be, this will occur like this. Okay. So this is not water, is some other liquid. Okay. So now let us go to the questions. Okay. So this is what we have, right? Okay. So this is what we hypothesize. And okay. So 1 to 2 has to be compressed liquid, right? Only liquid. So this should be 3. 2 to 3 is liquid plus vapor, right? That means 2. And 3 to 4 is saturated vapor. Okay. So which of this is not the correct one. 3 to 1, this is also not the correct one. This is the correct one. This is not the correct one. The correct answer is option C, right? So this is what we have concluded from normal thing. And then the other way is, the TV diagram. Okay. So this is temperature. TV diagram of substance is general. This is generalized TV diagram. Okay. So this region is a compressed liquid. This is saturated liquid. Okay. So this curve which joins all these points is saturated liquid curve. So this point is a critical point. So critical point is the point at which there is no distinction between vapor and liquid, vapor phase and liquid phase. Okay. And these are the saturated vapor liquid line. So here we have liquid plus vapor. Okay. This locus of all these points, this is a saturated vapor line. And So here we have a complete vapor, and once we go in here, we have a superheated. So there are two ways. So below, if you draw a line like this, okay, okay. So this is the boundary between these two. So anything below this, in the right of this line and below this line, so this region is superheated vapor region, and the region above it is the fluid region. Okay, ideal gas out. Okay. So from this also we can say that this is the saturated liquid, liquid plus vapor, and this is only vapor. Okay. So anybody has any question? We'll wait for 1 minute. Okay. Okay. So nobody has any questions. Then we'll go to the next question. Okay. So which is the next question? Which of the following statement is correct? So this is, we have already, similar question we have already done. Okay. Which of the following is all reversible processes are quasi-static process? Is this true? Or all irreversible processes are quasi-static? Is this true? Or all quasi-static processes are reversible? So remember once again that reversible processes are the process in which both system and surrounding come back to its initial position. Okay, and that is possible only in an infinitesimally small slow process. Infinitely slow process. Okay, and quasi-static process are the infinitely slow process. Okay, so hence we can say all reversible processes are quasi-static processes, but all quasi-static processes are not reversible. There can be an irreversible quasi-static process. Okay, the answer is option, you guessed it correct, it's option A. Okay, all reversible processes are quasi-static processes where the reverse is not true. Okay, so let me erase it and do it. Okay, so all reversible processes are quasi-static process. This is correct. All irreversible processes are quasi-static process. This is not true. We can have, but not. It is not a necessary condition. All quasi-static processes are reversible processes. This is not. All reversible processes are quasi-static processes, but all quasi-static processes are reversible. This is not. So this is correct. However, this is not correct. Okay. So option is option A. Okay. Anybody has any question? So this is also a very summarizing question on system. Just like we had a question which summarized the laws of thermodynamics. This is the question on summarizing the various types of systems. Okay. So what is an open system? So open system, I have discussed it, but let us briefly discuss. Open system is, say, both system and surrounding can change mass, and both system and surrounding can change energy. Okay. So that means delta M not equal to 0, delta E not equal to 0. It's an open system. Okay. Then let us go to closed system. So closed system, change in mass is equal to 0, change in energy not equal to 0. Okay. This is a closed system. Okay. Closed. Then what is a cyclic process? A process which come back to its initial position. Okay. That's a cyclic process. And system. The system is that part of the universe in which we are dealing. Okay. So now let us see. So interchange of matter is not possible in, okay, closed system. Okay. So this A has to be 3. Okay. Any process in which system returns to its original condition or state is called as a, okay, it's a cyclic process. That means B answer is 4. Okay. B will line up with 4. Interchange of matter is possible in a You guessed it right. Open system, right? That means C is 1. The quantity of matter under consideration. The quantity of matter or quantity of space under consideration in a thermodynamics is called as, guessed it right, system. That means D is 2. So we have A is 3, B is 4, C is 1 and D is 2. So now let us look at A is 2. This is not true. B is 1, not true. C is 4, not true. D is 3, not true. That means A option is not correct. B, A is 3, correct. B is 1, not correct. C is 4, not correct. D is 2, correct. But as 2 are wrong, this is also not the answer. So A is 2, no. B is 4, yes. C is 1, yes. D is 3, no. Okay. Now let's go to fourth option. A is 3, yes. Okay, A is 3. B is 4, yes. C is 1, yes. D is 2, yes. That means correct answer is option D. Okay. So, okay. So let us look at here. What explanation we have is, okay. Entries of list 1 are definitions of entries of list 2. Okay. Entries of list 1 are definitions of entries of list 2. Okay. So option is D. Okay. So is this clear to everyone? Okay. If anybody has questions, they can ask. So I'll wait for 1 minute. Otherwise, we'll go to the next question. Okay. So I'll wait 1 minute. If anybody has any questions. Okay. Nobody has any questions. So then let us go back to the next question. So what is the next question? The question number 16. Okay. So ice is kept in a well insulated thermal flask. Okay. So well insulated, that means delta E is change in energies, sorry, delta Q. Delta Q is 0. Is an example of which system? So ice kept in a well insulated thermoflask. Okay. So it's an insulated, that means it's delta Q. Thermoflask, that means there is no exchange of energy as well, right? So delta M is equal to delta Q is equal to 0. Okay. So let us again revisit that open system means delta M not equal to 0, delta Q not equal to 0. Closed is for system means delta M not equal to 0, delta Q. Okay. Then isolated means closed means delta M equal to 0, right? Delta M equal to 0, delta Q not equal to 0. Isolated would mean delta M equal to 0 and delta Q equal to 0, right? So this is matching with isolated system, right? With this definition. So here we are having isolated. So correct answer should be option B. Okay. Okay. Let me remove it. Okay, so answer is isolated system. Okay, answer is option B. So what is an isolated? In which there is no interaction between system and surrounding. That means delta Q is equal to 0. It is of fixed mass and energy. That means delta M also equal to 0 and delta Q is also equal to 0. More mass and energy, and as per the definition of isolated system, this is the definition of isolated system. Okay, isolated system. Okay, okay. So isolated systems option is option B. Okay. So anybody has any question? I will wait for 1 minute. So let us wait for 1 minute. So I'll give 2 minutes of time. Anybody wants to take a break and all? So we'll meet again at 7:30. So it's currently 7:28. So we'll take a 1 minute break. If anybody wants to drink some water and all. Okay. So anybody has any questions? If anybody has, they can ask. Otherwise, we'll go to the next question. Okay. So we'll wait for 1 more minute, and then we'll start at 7:31. Okay. Let us start with the next question. Question number 17. Okay. What is the question? Let us first read the question. The question is, a gas is contained in a cylinder. So we have a cylinder. Okay. And there is gas. A gas is contained in a cylinder is compressed. So here we have a piston like this. And then we are applying some pressure. It's a PEXT. and it is been compressed. So after applying pressure, what we have is like this. Okay, PXT. So volume has decreased. Okay, is compressed. The work required for the compression. The work required for compression. So work of compression. Let's say WCOM is equal to 5000 kilojoule. Okay, what required for compression is, so it's a during the process heat interaction of 200. So delta Q heat interaction, delta W is this, delta W is 2000. Okay, remember here we are not taking the we are not taking any sign convention. We are just, like, you can say, like, W mod of W is this, mod of Q is this, and it causes the surrounding to be heated, right? So this has to be remembered, the surrounding is being heated. So what we have to do is we have to find a change in the internal energy of the gas. Okay, so here what we will invoke is, we will invoke the first law of thermodynamics, right? So what is that? The first law of thermodynamics tells us that change in the internal energy is equal to change in the work done plus minus delta Q, right? So when I say plus minus, so this basically means what kind of sign convention we are using. Depending on sign convention, we can have delta E is equal to delta W plus delta Q, or we can have delta E is equal to delta W minus delta Q. So it all depends on what sign conventions are we using on W and Q. Okay, these are the options. So let us go and check the solution. Okay, what is the answer? So I'll give you, so before doing this, so I've given you, so I'll give you 3 minutes of time, 3 to 4 minutes of time to find the option. Okay, find the answer. Okay, so remember, gas is contained in a cylinder and work required is 5,000. So delta comp is equal to 5,000. Delta U is equal to 2,000. So this is absolute work. Okay, it's a absolute quantities, and then examiner has also asked the surrounding is heated. That means heat is lost by the system. 2,000 kilojoule of heat is lost by the system and it is going into surrounding. Okay, and then the examiner asking is what is the change in the internal energy of gas. Okay, what is the change in the internal energy of gas, not the change in the internal energy of the surrounding, but change in the internal energy of gas. Okay, so option A is 7,000 kilojoule. So minus 7,000, minus 3,000, plus 3,000, and plus 7,000. So here, as you can see, option A and option D are same, only there is a difference of sign, right? So you have to take into consideration of this thing. So first law is delta is equal to delta W plus delta Q plus minus, depends on what sign convention we are using. Depending on that, we can have delta E is equal to delta W plus delta Q or delta W minus delta. Okay, so I'll give you 3 minutes of time. You can try to answer it. Okay, is question clear to everybody? Anybody who, for whom the question is not clear? Okay, so take your time. I'm giving you 3 to 4 minutes. Anybody able to answer it? Anybody has any questions? Question is clear to everyone, right? So, what is the correct answer? Anybody would like to try? So I will give you a hint. So anybody has so answer will be either B or C, right? One of this is the answer. It is either minus 3000 or plus 3000. So remember it's kilojoule, okay? So that means it will be 5 or 5000 minus 2000 or 2000 minus 5000. So this is the hint which I am giving you. Okay. Remember to consider insert the sign convention. Remember to mention the sign convention which you are using, right? Whether you are using this or this, irrespective of what you are using, if you are using the correct sign convention, the answer will be the same. Okay. It cannot happen that by using this sign convention you are getting plus 3000 and by this you are getting minus 3000 or vice versa. If using both of these formula, you should be able to get the same answer. If you are not, then that means your conventions are wrong. So I'll give you 2 minutes to check it. Okay. So anybody able to answer it? So last 2 minutes I'll give. So anybody wants to answer it? Anybody would like to try? The last minute remaining. So last minute. Okay. So anybody would like to answer it? Anybody would like to try? Anybody got it? Okay. So let us discuss. So correct answer is this one, right? I gave you hint, either it is this or this. So correct answer is this plus. So, okay. So both the magnitudes and signs are very important. Okay. So let us try solving the question. So what we are giving is change in the internal energies plus. Okay. So this plus when I am saying is, this is the sign convention which I am saying. Okay. Okay. So also remember that work is required for compression. Okay. So W is of compression. Okay. So this is one thing which has to be noted. And the other thing is delta Q is for surrounding is to be checked. Okay. That means heat. That means heat lost by the system, right? Yes. Heat is lost by, or heat is lost by gas in the cylinder. Okay. Okay, that means heat has been transferred from system to surrounding. Okay, this has to be kept in mind. Okay, so given is what? Work of compression. Okay, change in internal energy is plus 300. Okay, and we are seeing a work of compression, that is delta W, has been given to us 500. And let me use this. Okay. Okay, so what we have is, this is the answer, and this is, we are given work of compression 5000 kilojoule. Heat lost to the surrounding, very important, delta Q. Okay, so from first law, you can either use delta U or delta E, anything is fine, is equal to plus minus delta Q plus minus delta W. Okay, so depending on the sign convention which you are using, you will use it. Okay, so depending on the sign convention under consideration, the signs of U and U, Q and W will be decided. Okay, so let us go down. So what we have in here is, let us, okay, so what is going to be our convention is, heat added to the system is what we are going to take as positive, and work added to the system, which is nothing but work of compression, is what we are going to take positive. So these are our sign convention, which is heat added to the system is positive and work of compression is positive. So as per our convention, W is what? W of compression. That means W of compression is positive. That means delta W we are going to take as plus 5000, right? Okay, and heat added to the system. Are we adding heat to the system? No, heat is being taken out of the system, right? Here you can check what we have is, causes the surrounding to be heated. That means heat is lost from the system. That means it is taken out of the system. Okay, that means heat is going to be negative, right? It is going to be negative. That means delta Q is minus 2000. Okay, minus 2000. Okay, this is unit of both is kilojoule, and here also kilojoule. Okay, so now we put it, delta U is equal to, so our Q is positive, that means plus delta W, and then plus of minus delta Q, right? That means it is 5000 minus 2000, right? Which is plus 3000, right? Plus 3000 kilojoule, right? Okay, so I will remove it. Okay, okay, I will remove it. Okay, so answer is this. Delta U is plus 3000 kilojoule. Okay, that means option C is correct, right? So anybody has any questions? This is clear to everyone? Okay, so remember, this is the first law, and we can have both things can be positive. Remember to take convention into, right? So this is the convention which is followed in most of the textbook, and we are going to also follow this convention. Okay, so as long as you use this formula of first law and you are able to give correct convention, we will have correct answer, right? 3000 kilojoule, option C. Okay, anybody has any question? No? So I will wait 1 minute if anybody has any question. Otherwise, then we'll go to the next question. Okay. So what is the next question? Which of the following is an example of closed body system? Okay, that means closed system. So let us again revisit. So open system means delta M not equal to 0, delta Q not equal to 0. Okay, closed means delta M equal to 0, but delta Q not equal to 0. Okay, and then last one is isolated. Okay, isolated system is what? Delta M is equal to 0 and delta Q equal to 0. So what we are asked is closed system. Okay, that means we are looking for this. So now lecture room, for clearly for lecture room, mass transfer is possible. Same is the delta Q is also not equal to 0. That means this is a open system. So this is not what we want. Human body, obviously mass transfer can also possible in delta Q is also not equal to 0. Okay, this is an example of open system. So car engine, can change. So for car engine, delta M is equal to 0, not equal to 0, and delta Q also not equal to 0, right? That means this is also not a closed system, right? This is also not a closed. So universe, so we have system plus surrounding is equal to universe, right? So with universe, what we can say? So let me write it here. So for universe, it cannot exchange mass with the surrounding. So delta M is equal to 0. Similarly, delta Q is equal. That means universe is an isolated system, right? But what we want is a closed system. So it appears that none of the options are correct. However, that is not. If you look closely at the definition of closed system and isolated system, you will find that closed system is a subset of isolated system, right? That's why all closed system we can say are isolated. That means option 4 is correct, right? Is this clear to everyone? So let us look at the explanation also. So, okay. So let me first remove this. Okay. So option is 4. Yeah, universe. Right? The universe is an ultimately closed system. That means it's an isolated system. Nothing can enter it or nothing can leave it. It is essentially an isolated system, but isolated, like I said, closed system is a subset of isolated system. Hence, this is the correct answer, right? Isolated system, right? This is a very tricky question, right? It appears that the question is wrong and none of the answers are correct, but however, that is not okay. The answer is option 4, universe. So anybody has any questions? Okay. So I'll wait 1 minute. If anybody has any questions. If no, then we'll go to the next question. Okay. So we'll go to the next question, which is question 19, which is the second last question of today. Okay. So in a state of thermodynamic equilibrium, so this similar question I have already taken it. So let us understand what is thermodynamic equilibrium. That means it is thermodynamic dynamic equilibrium thermodynamic equilibrium means change in temperature is equal to 0, change in pressure equal to 0, change in chemical potential is equal to 0, right? So this means thermal equilibrium, this means mechanical equilibrium, and this means chemical equilibrium, right? So for a system to be in thermodynamic equilibrium, it has to be in thermal equilibrium, mechanical equilibrium, and chemical equilibrium at the same time. So now let us look at the options. So this has to be one, option 2, option 3, and option 4. Okay. A system is in thermal and mechanical equilibrium. Okay. So this is not the correct answer because nothing has been mentioned about chemical equilibrium, right? System is in option 2 is system is in thermal and chemical equilibrium. This is also not correct because nothing has been mentioned about mechanical equilibrium. So system is in, so option 3 is system is in chemical and mechanical equilibrium simultaneously. So this is also not correct because nothing has been mentioned of thermal equilibrium. So let us go to option 4. So system is in thermal, chemical, and mechanical equilibrium simultaneously. Okay, so this simultaneously is important, and thermal as well as chemical as well as mechanical equilibrium, like we mentioned. So this satisfies the definition, and hence option 4 is correct. So the answer of question number 19 is option 4. A system has to be, when a system is in both all thermal, chemical, and mechanical equilibrium simultaneously, then we say that system is in thermodynamic. That is essentially the definition. Okay. So anybody has any question, they can ask. Okay. So I'll give 1 minute, 2 minutes for anybody to ask the question. Okay. Otherwise, then we'll go to the next question. First, let us understand. So option is option 4, which is this one. A system is in thermal, chemical, and mechanical equilibrium simultaneously. Okay. And for a state of thermodynamic equilibrium, the system should be in thermal, chemical, and mechanical equilibrium simultaneously. Okay. So now we'll go to the last question. Okay. What is the last question? The internal energy of a system is, option is path function, state function, both path and state function, and none of this. Okay. So anybody would like to try it? I'll give you 1 minute to try it. Remember, internal energy. Okay, it's an internal energy. Okay, we also, so just by looking at the option, we can say that it has to be either a path function or a state function, right? You cannot have this, right? And you also cannot have. So just by looking at the question is, option 3 is not possible, option 4 is not possible. Whatever we have is path function and state function. So just remember, try to remember, we have already discussed it in this class. What is the definition of path function and what is the definition of state function? Okay, so as a hint I am giving, let's say this is thermodynamic property V, this is thermodynamic property, this is P, this is V. We have this point, which is initial point. We have this point, which is final point. Okay, and then we are joining like this. So let's say, so we are joining like this, we are joining like this, we are joining like this. Let's say. So let's say 1, 3, 2, 1, 4, 2, 1, 5. So they are 5 different ways of reaching from 1 to 2. So I will give you a hint is that one is that what are those properties which do not depend on path. Okay, those are called as what? And those who depend on path, that means path functions are the functions or the properties which depend on the way we take, right? For example, let's say some q is a path function. So q of 152 125 to 2 will not be or may be equal to q of 142, which is not equal to q of 132. So such properties are called as path function. Okay. And then those properties, let's say the properties, let's say r. So r is a state function. So in that case, r132 should be equal to r142, which should be equal to r152. Okay. So such properties are called as state function. Okay. So what is an internal energy? So with this definition, we can also look at what is internal energy. Let's say first law of thermodynamics, what does it say? Delta U plus minus delta Q. Okay, that means anybody would like to answer? I'll give you 30 seconds. 30 seconds to 1 minute to find. Right? What is internal energy? So it will be path function? No. It will be a state function, right? Because it does not depend on the path. It depends only on initial and final state. So internal energy is a state function, right? So let me first remove it. So what is the answer of question number 20? It's going to be, right? It's a state function. Option is 2, right? Right? What is it? State function, right? So the internal energy is a state function. It only depends on initial and final state of the system, right? Irrespective of its form, right? So I hope everybody enjoyed this question, and if anybody has any questions, they can ask now. Okay. So I'll wait for 1 minute if anybody has any question, and then we'll go close this session. And I thank you all to attend for attending this session, and I hope you have able to learn something from it. Your knowledge has increased, and your doubts have been clarified. If you have any questions, okay. So those who do not have any questions, they can leave, and those who have any question, they can either unmute themselves and ask, or if they want to ask on chat, they can also do that. Okay. Right. So nobody has any questions. Okay. Anybody has any questions? Okay. So nobody has any questions. So I think we can close this session. Right. Okay. Then I will be stop sharing, and then if anybody has any question, nobody has any questions, right? So then I thank you all for attending this session, and I hope to see you again in the next section, which we will be having in next week. Okay. So thank you and good night.